Okay. Let's get coding. Nice! This is my game Currents. It's a simple grid-based circuit board simulator. Last devlog I made it so you can place down different components on the canvas. Now I want to make it so you can remove components by right-clicking them and also toggle them by clicking them again. Right-clicking was pretty easy. I just copied the same code that's used to place them, but changed the input to a right-click and then set the atlas ID to -1, -1. Simply put, if the atlas ID is -1, -1, it just removes the title. Next up, it was time to make the components toggle whenever you right-click them. This was a little more difficult because a couple of the components need to rotate when you toggle them, but that can't be that hard, right? I'm sure there's just like a simple rotation function that's easy.
To apply. For example, if you want to rotate 90 degrees, then you would need to transpose it first and then flip it horizontally.
So I gave up on trying to rotate the tiles and just made a new component for each of the rotations. To implement it, I just used a heck ton of if statements, which is probably a really inefficient way of doing things, but may I remind you what the code for Undertale looks like. Hey man, if it works, it works. Speaking of working, I have to get these components working because currently, this game is more of a pixel art editor than anything else. Here's a basic summary of how each component works. Batteries are power sources that you can toggle on and off. Conductors are like wires that transfer power. They also have a memory mode, that means they stay on even if they're no longer powered. Inverters produce a signal from their butt unless the block in front of them is powered, then they turn off. And movers are like pistons in Minecraft that push the block in front of them forward when they're powered. That's all the components. They seem pretty simple, but implementing the logic for them definitely wasn't. I tried of thinking of ways to make the components functional, but every solution I thought of caused issues. My first idea was to make each component only worry about what was around it, but this meant if two conductors are next to each other and the battery that's powering them turns off, they'll look at each other and see that the other one's on, so they'll think they're still being powered, causing them to stay on infinitely. I asked our Lord and Savior ChatGPT, which came up with some ideas like this propagation method, where you start at the power sources and check everything from there, or this branch method where you group all the conductors together before calculating if they're powered. But these methods had a few issues, mainly surrounding the order you'd check things in, and the fact that inverters are dependent on what's in front of them. So they wouldn't work. But with the help from my viewers and a bit of planning later, we eventually came up with this. First, scan the page for batteries and power all conductors that are connected to them. Then scan for inverters, check everything that's connected to them to see if they should be powered. Then update all connected conductors behind them if they haven't yet been turned on from batteries. And while all that happens, everything that gets checked gets added to a list so we know what we've already checked. I tried this method on a few circuits by hand and the idea seems promising, but I'm sure implementing it will take some work. So let's get started. I created this color rectangle node that scans every tile on the x-axis, then moves down once it finishes the road. I said moves down once it finishes the road. It doesn't actually scan anything yet, it just kinda moves, but someone in chat told me about dictionaries which I can use to keep tabs on what tiles have been checked, so I'll have to set that up as well. They also said putting component variables in a dictionary would be a good idea, so I should probably do that too to save my future self some issues. But all this thinking hurts my brain, so I'm gonna have to implement all that next time. Thanks for watching, sorry for the cliffhanger, have a great day, and I love you, bye!